In college algebra, we started 5.4 systems of nonlinear equations. Most of these are like parabolas intersecting with lines or a line intersecting with a circle. And so we have multiple answers. And we still have the option of substitution or elimination. So very similar to 5.1. It all depends on how it's presented. I would look at 1 and 2 and look how different that is typed from number 3. Number 1 and 2, we have this mix match of like an x to the first, x to the second. On number 2, it's a big mix match because we have x to the second. That squaring is going to give us another x term, and then y squared y to the first. So 1 and 2, we're going to use substitution, because elimination would make it a big mess. Whereas number 3, elimination will work perfectly because they're lined up, we have similar terms, it's ready to go for elimination. But let's solve number 1 with substitution. I would pick the easier equation right here and solve for one variable. So if we solve this one for y, we get 3x minus 9. We're going to substitute this value right there. Hence substitution. So let's write that. Let's distribute that 2. Oops. And I see an x squared and an x. This is a sign that we need to factor. Let's move everything to one side so we can factor. And by the way, if we can't factor, you can do quadratic formula, but you still need to move everything to one side. I like the x squared term positive, and it's already positive, so let's move everything to the left side. We have negative 18 plus 10, that's negative 8. Let's add an 8 to both sides, and we get that. We need two numbers that multiply to 8, but add to negative 6. And those are negative 4 and negative 2. So x equals 4 and 2. Don't stop there. We need y. We need to know where these two things cross. So let's plug in 4. I'm going to plug it into the easier equation. And we get 3. Let's plug in 2. And we get negative 3. So final answer, 4, 3, and 2, negative 3. All right, let's try another one. I would approach it the same exact way. I would use substitution. And I would solve for one of the variables here. Let's solve for x. So that equation becomes x equals 3 plus y. And I want to plug that in for x right here. So just be careful when you do it. We have 3 plus y minus 2, y plus 3 squared, all equals 4. Do a little simplifying. Let's FOIL out those two squared binomials. You square the first, multiply them, and double. So we get 2y. And square the second. And let's do it again for y plus 3. Square the first, multiply the numbers, and double it. And square the second. We have 2y squared plus 8y. We have 1 plus 9, but we need to subtract the 4, so we end up with 6. We have a GCF. Let's take out a 2. So lastly, y plus 3, y plus 1. And we know y is -3 and -1. Let's plug it back into one of the equations. Let's plug it into the top. Careful with those minuses. And we get 0. Let's plug in -1. And we get 2. So final answer is 2, -1, and 0, -3. All right, let's do one more. And this one, I would use elimination. And that's because the variables we have like terms and the variables are lined up perfectly. One catch, if I combine the two, nothing cancels out. I would multiply this one by -1. So I'd leave this one as is. And I'd multiply this one by -1. And then when I combine the two, the y's will cancel out. And I get something very simple looking. Square root both sides, and we get plus or minus 1. Let's plug both of those in. Let's plug it into the second one. And we get plus or minus 3. Notice if we were to plug -1 in, look up here. If I make this a -1 up here, don't I get the same exact result? So you don't really have to plug in another one because you just get the same answer. Our final answer is 4 coordinates. And that's it. See y'all later.